Hello, and welcome to the Daily Space for today, Wednesday, December 9th, 2020. I am your host, Annie Wilson. Most weekdays, we're here putting science into your brain. Usually Wednesdays are for Rocket Roundup, and today is no different. So, let's get to it, shall we? But before I begin, let me state that I'll try my best with pronunciations, but I'm bound to make a few mistakes. My deepest apologies. All right, first up, on December 3rd at 1:14 UTC, a Russian military Soyuz 2.1 Bravo was launched from LC-33-3 at the Plesetsk Cosmodrome in northern Russia. On board were 4 satellites, a trio of GoNet satellites, and a small military satellite. For those of you that are curious, GoNet means messenger or courier in Russian. The GoNets trio will join an existing constellation of at least 12 other GoNet satellites already in operation. Together, the GoNets constellation will continue to provide store and dump communication services for areas that can't receive a cellular signal. Basically, terminals in the network ping the satellites periodically to let them know that they are available for transmission. Then the satellites transmit any stored data intended for that terminal. This is in contrast to most commercial communication satellites, which don't store any data on board, but retransmit it back to the Earth as soon as it's received. Current uses of the GoNets network include sending and receiving messages or data globally, including pump stations for gas and oil pipelines, tracking cargo containers on ships, and communications for humans in really, really remote areas. According to Roscosmos, the passenger satellite ERA-1 is a nanoscale service platform developed for the Russian Defense Ministry, designed for testing advanced microdevices in orientation and astrogation microsystems. No other information was released about the small sat. As expected, there was no live broadcast. Head of Roscosmos, Dmitry Rogozin, later confirmed via Twitter that the satellites were on orbit. But just because there was no live broadcast doesn't mean that we don't have launch video. Reminder, rocket launches are loud. All right, next up on December 5th at 3:58 UTC, China launched a Long March 3 Bravo from LC-3 at Xichang Satellite Launch Center in southwestern China. On board was Gaofen 14, the next in China's series of high-resolution optical imaging satellites. This particular Gaofen 14 satellite is an optical stereo imaging satellite. This means that the satellite can take 2 images of the same target from different angles. When the images are processed, it is possible to extract elevation from the data, which can then be used for topographic mapping and creation of digital elevation models. Reminder, rocket launches are loud. That's it. That's all there is to that launch. Or, we get to watch it again. All right, our last launch of the week was a SpaceX Falcon 9. On December 6th at 16:17 UTC, Commercial Resupply Service Mission 21, also known as CRS-21, started its journey to the International Space Station from historic LC-39 Alpha at Kennedy Space Center in Florida. Technical difficulties. CRS-21 marks the first flight of a Dragon 2 as a cargo resupply ship. Cargo Dragon 2 features a different pressure vessel than the Crew Dragon, so although the two craft share a name, they aren't the same. Cargo Dragon 2 doesn't carry people, so there's no need for things like windows or an abort system. As far as upgrades from the Cargo Dragon 1, the newer craft has about 20% more volume, and it ditches the extendable solar panels for wraparound panels on one side of the trunk. The other side of the trunk has radiators. Additionally, Cargo Dragon 2 docks itself to the space station without assistance from Canadarm2. The IDA-3 docking adapter CRS-21 docked to itself was brought up in the trunk of CRS-19 Dragon in July 2019. The primary payload for CRS-21 was the Bishop airlock, the very first commercial airlock on the International Space Station. Built by NanoRex, Thales Alenia Space, and Boeing, it will be used to deploy CubeSats from the ISS more efficiently. The current method involves using an equipment airlock in the Japanese Kibo module, but it is low capacity. That particular airlock only opens 10 times a year, with half of those instances reserved for JAXA, Japan's space agency, and the other half allotted to NASA and commercial partners. The Bishop airlock will be attached to Node 3 port. Also on Node 3 is the Cupola module and the Bigelow Expandable Activity module. Also on board CRS-21 were supplies for the crew and new science experiments. For those of you keeping score at home, this was the fourth flight for booster Bravo 1058. There were two firsts for NASA with this mission. The booster previously flew on a non-NASA flight, and it has flown more than once. It had a successful landing on Of Course I Still Love You. Unlike a Falcon 9 with a satellite payload, there were no fairings used for this Dragon launch, and therefore none were recovered. Reminder, rocket launches are loud. You can see the venting, the last bit of the countdown. Here it goes. You ready? And of course, with the SpaceX launch, what goes up must come down.
There's a view from our drone ship. Here comes Falcon 9.
Chico.
And Falcon 9 has landed once again. That is the 68th successful first stage recovery. This mission also marks the 100th successful flight of Falcon 9. It's also the 35th time we've landed successfully on our drone ship. Of Course I Still Love You.
All right, so I mentioned that the Galfen 14 satellite is an optical imaging satellite. I wasn't really sure what that was, so I asked Gordon, aka Keeper of Maps. The following is his explanation. Most people have stereoscopic vision, meaning that they can see in 3 dimensions and thus discern where things are located spatially. This is because their eyes are slightly separated horizontally. Each eye sees a slightly different image, but the brain combines the two images, allowing one to perceive 3 dimensions. This can be done with photographs too. In the early days of photography, stereoscopic images were created by special cameras with a pair of lenses next to each other. The resulting image was printed on a card that, when viewed through a stereoscope, could be viewed in 3D. This is what a stereograph looked like circa 1908. The two images are similar, but not identical. The parallax means that the images closer to the camera will appear in slightly different positions relative to the objects behind them. Amusingly, this stereograph is of someone looking at a stereograph with a stereograph in their sitting room. And this is a picture of a home stereograph, which was the most popular type of stereograph in the 19th century. It allowed the left eye to view the left image, while the right eye viewed the right image. The geometry was such that it tricked the brain into thinking it was looking at a real scene and not just a couple of photographs. Jumping forward a few years to 1939, yes, really, the Viewmaster appeared on the scene. It underwent small changes over the years to become the iconic red gadget that you put little cardboard discs in with teeny tiny slides. And jumping forward a few more years to the late 80s, early 90s, virtual reality headsets appeared on the scene. They allowed the viewer to view 3-dimensional images that reacted according to the direction they were looking. The technology has changed a lot since they first appeared, and now you can pick one up for a relatively small amount of money compared to what the first ones cost. They're used now for all sorts of applications, from medical training, military training, gaming, and remote sensing. Speaking of remote sensing, that's just observing something from far away. Before satellites, aerial photographs taken from airborne platforms such as airplanes, balloons, and even kites were used to create stereographic images, which cartographers could use to create topographic maps versus stereogrammetry techniques, also known as photogrammetry. The same basic techniques can be used with satellite imagery and even radar data, which is called radargrammetry. This image shows how the ICONOS satellites operated by Satellite Imaging Corporation collect stereographic images from low Earth orbit. The data can be used for a variety of applications, such as detecting changes due to erosion or earthquakes or some other natural process. For example, you could create... my apologies. For example, you could compare the 3-dimensional profiles of a volcano over time to identify small changes caused by a buildup of magma underground. If the 3-dimensional profile of a volcano starts changing, this could be an indicator that an eruption is going to take place. I hope that explained what stereographic imaging is, how it is collected, and a few examples of what it is used for. If you enjoy this kind of in-depth explanation, let us know and we'll try to find other topics to explore. And finally, to wrap things up, here's a running tally of a few spaceflight statistics for the current year. There are currently 5 toilets in space, 2 are installed on the ISS, 1 is on the Crew Dragon, 1 is on the Soyuz, and there's 1 that is not yet installed, I think. 3 toilets have burned up in the atmosphere. Humanity has put a whopping 1,178 satellites into orbit. That includes those launched from other in-orbit craft, such as the International Space Station. Directly from launches were 1,147 satellites, and 833 of those were Starlinks. So far, there have been 103 total orbital launch attempts for 2020, including 10 failures. I keep track of orbital launches by where they launched from, also known as spaceport. Here's that breakdown. China, 36. USA, 34. Kazakhstan, 7. Russia, 6. French Guiana, 6. New Zealand, 6. Japan, 4. Iran, 2. India, 1. Israel, 1. And your random space fact for the week is that there are 100 $2 bills on the moon. They were left in the lunar module by the crew of Apollo 15. And that rounds out our show today. Thank you all so much for listening. I have been your host, Annie Wilson. Today's script was written and edited by our wonderful team, including Gordon Dewis, Eric Mattis, Beth Johnson, Allie Pelfrey, and myself. Our web content will be produced by Beth Johnson. Our executive producer and fearless leader is Dr. Pamela Gay. The Daily Space is a product of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. We are here thanks to the generous contributions of people just like you.